Hey guys, D-Rave here, and I'm here to talk about one of my crazy ideas that I've been holding on for like 10 years, that started back when I was in college. And I nicknamed it SHME, the Solar Harvesting Mitochondrial Engine. This is what I refer to as my biofuel cell quite often. So we're going to talk about there's two big keys here to the mitochondrial biofuel cell, and that's going to be cyanobacteria and mitochondria. And apologize if this gets a little crazy here in a minute. So, one of the reasons we use cyanobacteria, they're one of the oldest known fossils. They're over 3.5 billion years old. The chloroplast, which makes the food for the plants, is actually a cyanobacteria living within the plants. There's been speculation that somehow, basically, there was a symbiosis early on and down the chain, but endosymbiosis, as it talks about there. So we don't. I believe that's not 100% true fact during the Cambrian era, but so I used to always joke, mitochondria. Why mitochondria? We all know mitochondria is the powerhouse of the cell. It's kind of the joke. And my camera covers there would take sugars, converts them down to ATP, which is then broken down in electron transport chain to create energy. So that's how we use sugars to actually create energy, or ATP. Let me see here. I have my apologies. I have these notes. I have my Scrabble written notes, and then I have the stuff from a long time ago here. So this talks about G1 made ATP during hydrolysis, 7.3 kilocalories per mole. Doing a few calculations here, which we'll talk about later. So cyanobacteria, a little bit about them. They can perform not only oxygenic photosynthesis, but respiration based off nitrogen or sugar and CO2, I'm sorry, simultaneously within the same metabolic pathway. There are over 2,698 types of cyanobacteria, which gives a large variety of cyanobacteria to work with. It might not just be a one fixed solution. We might be able to find other types of cyanobacteria that work better in the environments and create more, energy. Um, Please excuse this. I literally made this in Microsoft Paint. I don't know why it's cutting off the top there. So blue, of course, is going to be a water or aqueous solution. The cyanobacteria should basically, I'm hoping to get them in a free-floating kind of so that they can absorb. The purple dots, of course, are going to represent our enzymes or transporters that are going to basically take the sugar and then move it down to the purple, which are the mitochondria grafted on the gray panel. So basically, a panel that sits underneath the water with mitochondria grafted to it so that the transporter enzymes can then take the glucose, fructose, or whatever sugar that is created by the cyanobacteria and deliver it down there. Fun fact too, cyanobacteria, I didn't have this on the last slide, emit free electrons to their environment. So there's potential for this that it could, really be big. And I've referenced in some of my videos, when I first started talking about this, there was nobody that I knew of, that there was nothing on this. I could not find anything. I used to lie to get to websites, to get like medical information and other information, like, basically reviewing papers kind of deal. Um, but later on, as I did check back on this, there were two people or companies, whatever, that, that really were starting to get this. So we had Dr. Jeffrey Way of the Harvard Wise Institute was doing a lot of work on biofuel cells, as well as Shelley Mintier, the professor of chemistry at the University of Utah. Um, but the other big one here is Protero, a biotech company in New York that basically was taking cyanobacteria and using them to try to replace commercial consumer products like salt and sugar. They showed basically that they could take cyanobacteria, vats of cyanobacteria, and replace acres and acres of sugarcane fields and produce a commercial grade sugar as well. I highlight them because they showed that the true ability of the cyanobacteria, and also they developed a enzyme to extract the sugar, which is one of the key components here. The other two, Dr. Jeffrey Way and Shelley Mintier, focus more on the mitochondria side. I believe Shelley Mintier used her formula on one of these papers. Yep. To try and using Shelley Mintier's formula, I was, able to show, and I'm sure there's problems possibly in my math, but I was able to use Shelley Mintier's calculation to show that the amount of energy based upon per square inch of my biofuel cell to a solar panel, that off just glucose, not a more complex sugar, that I should be able to make the same, if not more, energy than a solar panel. Now, of course, the whole concept of this biofuel cell as well is that we are trying to create an energy company that doesn't take a lot to start up a fresh new plant. So the production of energy is not always the hard part. It's actually the transportation of energy over long distances. So the idea is that I could start up smaller energy companies across the Midwest and internationally, giving better energy independency to a bunch of smaller towns. Of course, I probably wouldn't take them off the national grid, but I could also probably lower their energy cost as well across the board. And as I talked about earlier, it can go through respiration as well here. So the fact is that even if weather conditions got bad, if there wasn't sun for days, if it was snowing for days, we can still figure out a way to create energy out of this. This was created thinking about how to improve on green and clean energy, as well as trying to figure out a way to lower the cost, because a lot of these materials for solar panels, and like we know about graphene, graphene is really good at conducting electricity. However, it's hard to make. Let me see here if we can find anything else that can add to it. Of course, we got the electron transport chain and a little bit about how it would work there. Calculating. I think that's going to be it, guys. But this is something I've wanted to try to get off the ground for I don't know how long. It's why I started streaming. It's even why I've got a YouTube or a TikTok right now. The idea was to be able to create this company and basically not only help a lot of people, but generate the money that I need to run other organizations and help a lot of other people. You lead by example, but we all know that if you don't have money, thoughts and prayers, and thoughts and prayers don't really help a lot. So, if you thought this was a cool idea, if you think this is something you would love to work on, like, subscribe, message me. I don't care. I have spent years trying to get this out there, and of course now it's kind of more common knowledge, which is slightly heartbreaking. Another reason why I'm just putting it all on YouTube now. Yeah, I hope somebody helps somebody out there. But have a great day, y'all, and thanks for dropping in.